This is Chestacho.
To comprehend black holes, a fundamental understanding of relativity is essential, divided into special and general relativity. Albert Einstein introduced special relativity in 1905, concentrating on how objects move relative to each other and how an observer's perception of space and time alters with movement. This theory is beautifully encapsulated in Minkowski spacetime, a geometric concept. General relativity builds upon special relativity, incorporating the effects of gravity, critical for understanding black holes. While special relativity simplifies by omitting gravity, general relativity integrates it, as demonstrated in Einstein's field equations that describe spacetime's curvature due to gravity. A crucial aspect of special relativity is the equation E equals mc squared, linking energy, mass, and the speed of light, showcasing the profound connection between mass and energy. This equation is central to the destructive potential of nuclear weapons and vital for black hole physics and the aspirations for nuclear fusion as a clean energy source. Special relativity is intimately connected with James Clerk Maxwell's electromagnetism theory, particularly regarding the constant speed of light, which remains consistent irrespective of the observer's movement. This consistency of light speed is a fundamental aspect of relativity, suggesting that physical laws are uniform across different frames of reference, emphasizing the relative nature of motion. Frames of reference are a crucial concept in special relativity. They are exemplified by scenarios like a train moving at a steady speed, showing how motion is perceived differently depending on the observer's frame of reference. In such scenarios, whether something is stationary or moving is entirely dependent on the observer's perspective. This relativity of motion extends to all physical phenomena. These concepts lead to Lorentz transformations, mathematical expressions that correlate time and length measurements between different frames of reference, explaining phenomena like time dilation and length contraction. For example, time measured by someone on a moving train, proper time, differs from time measured by stationary observers. Length contraction is similarly observed, where an object's length, like a pole in motion, appears shorter to a stationary observer than in the moving frame. The derivation of E equals mc squared starts from the momentum of massive bodies and light pulses. It introduces a hypothetical scenario with light pulses and mirrors to explain how mass can be conceptualized as a form of energy. This ties back to the nature of protons and neutrons, suggesting that much of the mass in everyday matter arises from the energy of particle motion and interactions, similar to the light and mirrors model. Maxwell's electromagnetism theory is further explored, showing its foundational role in both special and general relativity. This theory revolutionized the understanding of electric and magnetic fields, demonstrating that they exist independently of the charges and currents that create them. It also revealed that fields can produce other fields, as in the generation of magnetic fields by changing electric fields. Maxwell's equations implied the existence of light as a fluctuation of electric and magnetic fields. These fields propagate through space as waves, with visible light being just one segment of a broader electromagnetic spectrum. The link between electromagnetism and general relativity is highlighted, with both theories involving field concepts and differential equations describing field behavior. In conclusion, Einstein's general theory of relativity, building on these principles, describes gravitational fields in terms of space-time curvature. It offers a geometrical understanding of massive objects, including black holes, distinct from electromagnetism's emphasis on charges. Hence, special and general relativity, together with Maxwell's electromagnetism, form a comprehensive framework for understanding the fundamental nature of space, time, and energy.
This is Chestacho.